G'day viewers. In this segment I'll talk about differentiated services, which is one vision for quality of service in the internet today. Okay, so in differentiated services, what we're really trying to do is provide a small number of different classes or grades of service. So this is a premium and regular service, network service if you will. And it's one kind of quality of service which is gradually being deployed in the internet today. For motivation, let's return to our classic scenario of a user who's sending Skype and BitTorrent traffic at the same time. Actually, they're just examples of kinds of traffic. Instead of Skype, you might imagine remote desktop and gaming traffic and so forth. I really have in the picture here down on the left the pink packets and blue packets, and they require different kinds of service. You can see the blue packets are marked as priority VIP packets. Maybe your gaming or remote desktop or Skype traffic is more time sensitive than your other traffic and you would like it to receive preferential treatment. What we're really after with differentiated services is to work out how we'll be able to provide that kind of preferential treatment. And what we're going to do, as you might have suspected all along, is combine some of the building blocks that we've known about because we've seen them in earlier lectures. So where we want to get to is this idea of being able to treat different kinds of traffic, the different grades, differently in the network. We're only going to have a few different grades of network service. I've called them here gold, silver, bronze. You could call them anything you like. We'll see some different names in a moment. Obviously, for the different kinds of service or the different grades of service, they're going to get better or worse treatment inside the network. So some with the gold will receive preferential network service compared to the silver and the bronze. But of course, to get that from your ISP, you probably have to pay for it. And then all we need to do to complete the picture is map the traffic from the different applications we're running to the appropriate kind of service we would like them to receive in the network. So here's the overall architecture. And you can see there are three important pieces here. The first piece is that the user is marking the packets with the service they would like the packet to receive. So all packets that come from Skype might be marked to receive gold level service here. So this is done right here at the edge of the network by the user. The packets then go into the network, and then we have steps 2 and 3. In step 2, the network right here is policing the traffic that is entering it at its boundary as it goes into the network to make sure that it's appropriate. Appropriate would mean that you're not asking for too much high priority traffic, and really essentially that you're getting what you paid for. And we'll see how we use token buckets to do that. You can see all of the pieces are coming together here. And the third piece is within the network itself, so within the ISP here, we need to actually provide the different kinds of service so that gold service comes out ahead in some respects of silver and bronze service. And we'll do that by using weighted fair queuing at routers. And there are other schedulers that could be used too. But in this overview of differentiated services, I'm really just going to take a quick peek and show you the most basic option. So let's go through each of those three different parts of the architecture in turn. First, marking packets. How are we going to mark these packets? We actually sort of need to flip some bits on them and carry them through the internet so that different routers will know which packet belongs to what kind of service. Well, very fortunately, there are some bits in the IP header. This is the IPv4 header, and they're inside this differentiated services field. They're also in the IPv6 header in a traffic class field. These bits carry a 6-bit DSCP, that's a differentiated services code point field, which specifies the kind of quality of service the packet should receive inside the internet. Actually, these bits have been rebranded some number of years ago. Originally, they were called the type of service bits, and they were able to specify whether the packet should receive low delay or high throughput, all of this sort of stuff. But no one really knew what to do with quality of service in those days, and so they languished. So they've really recently been relabeled so that they can be used for something that's closer to their intended purpose. But luckily they were there because IP header space, at least for IPv4, is some of the most scarce and expensive real estate in the world, I guess. Okay, so now we know the bit fields where the marks go. We need to work out what to put on them. Well, In the differentiated services architecture, there are many possible different DSCP markings that could be put on a packet to request a different kind of service. Actually, it really depends on what the network operator is going to provide here. Differentiated services is really a toolkit, and you can make up all sorts of quality of service offerings. So your network ISP will decide what handful of services they'll support and exactly what they will mean. But I've shown here in the table just some different common differentiated services names. One kind of differentiated service is just a service that has a code point of 0. That's the default forwarding service, and that is, surprise, best effort. So you get just what the internet already does. This is appropriate for what's called elastic traffic, and that's traffic that can be spread out over whatever time is available. So BitTorrent is a good example of this. It's a bulk download. It just goes as fast as the network has spare capacity for it. And beyond this kind of service, I have 3 other services here which represent kind of more stringent qualities of service. So where the network will actually do a little more than best effort. There's one kind here which is assured forwarding is the name that's used. It's a little unclear exactly what this is, but we can think of this as some kind of enhanced forwarding. It's not best effort, it's enhanced effort. There are many different DSCP values that are used here. I've shown a typical range for different grades of this service in different ways. But the need that this service provides is traffic that has some kind of average rate that it requires and that the network is going to provide. Streaming video is a good example of this, because you would like a certain rate so that you can get through the right quality of your video, but maybe you don't care particularly about the exact delay you get because it's a streaming scenario. Beyond this, we have expedited forwarding. This is for real-time traffic, like voice over IP or gaming and so forth. This is traffic for which you want the network to provide low loss and low delay. And then finally, there are other more historical kinds of forwarding values. In this field, old precedence values from previous uses of the field can be used. And they really specify different priorities of traffic. And I've just shown an example here, network control traffic. This is high priority traffic. A good example is traffic which is sent by the routing protocol between all of the routers to help maintain the routes. Well, you'd really think the network should treat that as high priority and deliver it so the routers can work out which way to send all of the other traffic. So you can see here that quality of service can actually be useful for running our own network. Okay, so now we have all of the markings and we know something about what they mean. All we have to do now really is have traffic be marked by the users. Now exactly what application is marked with what DSCP value for service is a matter of local policy. It depends on how it's configured in the user network at the end. And the reason it's local policy is it depends on your objectives. I picked an example here. Should gaming traffic be marked as expedited quality of service or not? Well, I don't know. If this is you at home, yeah, absolutely, because you want a good gaming experience and latency really matters. If this is your business at work, they might not be really thrilled to be paying for extra money, for all of the premium service that they're buying for that to be used on gaming traffic. They might think their VoIP calls are more important. So there's a matter of local configuration. In either case, it's done on the user side as traffic goes into the network. This could actually be done on the host itself as part of either the operating system or the application. This is actually quite helpful when you can do it because really it's the application or the local operating system from which the traffic is generated that has the best idea what that traffic actually is and hence what priority it should get. Or it could be done by a device inside the network, a kind of middle box as traffic is going through. You might use the heuristics like the ports on which the TCP or UDP traffic is going to decide whether it's high priority or not. This is actually a little tricky to do inside the network because if the traffic was encrypted, for instance, it might be a little difficult for the network box to tell what kind of traffic it is and how important it is in terms of quality of service. So there's another twist which makes it difficult. Okay, step 2, policing at the edge of the network. What's this all about? Well, this is really about 2 things. The network at the boundary, as the traffic comes into the ISP network that's going to implement quality of service, it needs to check that incoming traffic to see that it meets whatever service contract has been agreed with the user. For instance, you would not want to, if you're the ISP, allow more expedited traffic or packets with expedited markings into your network than you've already agreed to accept from the user, and more particularly that the user has already paid for. If they haven't paid for it, you might just not want to give them expedited service. And more than that, you might also do a little housekeeping. You would only pass in allowed quality of service markings. For instance, users should not generally be passing routing traffic into the network. So if they have any markings for network control traffic that should be treated as very high priority, these markings might be scrubbed, because you're only going to allow that kind of traffic to be generated inside your network. You're not going to give that high priority to the different users. Now, policing, just to tell you a little about how policing is done, you might have guessed the answer already. It's done with a token bucket. We simply run a token bucket machine, and that way we can assess the rate and the burstiness of traffic, and we can decide whether too little or too much traffic of a certain kind is coming in. If too much is coming in, then we can simply demote the traffic which is out of profile. We could discard that out of profile traffic if there's too many high priority packets coming in, but what is often done instead is to demote it. If a user marks all VoIP packets as high priority, and for some reason there's a lot of VoIP traffic, and so there's too much high priority traffic, more than they paid for, what the network can do is it can demote and change some of those markings, and it can remark that high priority traffic to be just best effort traffic. That way, if there's enough bandwidth in the network, it will get through. And if there isn't, it won't get through, and the user will find they're not getting the service they want and have to buy more service or use the network less or something. And actually in DiffServ, other kinds of demotions are possible too. For instance, these packets might be prioritized for a different kind of loss. If you've got too many high priority packets, you might let the extra ones in, but mark them as the ones which should be dropped first. So that's policing. What about the third component, forwarding? Well, here we really have to work out how the packets are going to be treated at routers to provide the different kinds of services. And the answer is that the routers inside the ISP network will use weighted fair queuing as a scheduler instead of FIFO. If we use weighted fair queuing and adjust the weights appropriately, we will get different kinds of service. Now, when we talked about weighted fair queuing before, we talked about different traffic flows going into a queue and drawing from those queues. Here, the different traffic flows are the different kinds of service. So we'll have a different queue for premium, regular, best effort, expedited, and so forth. And what we'll do as traffic comes in to a router is we'll use the markings on the packet, the DSCP code points, to map the traffic to the appropriate queue so it'll get the service it wants. We're just going ahead to look at that in a little more detail. Here is a picture of a router here, so you can see what is going on. And we have three kinds of service here. I have expedited forwarding, default forwarding, and assured forwarding. So they're going to be three different queues. Packets as they come in, we'll look at the markings on them and put them in the right queue. And a weighted fair queue scheduler is used here. And you can see that I have different weights placed on here. The expedited forwarding has the highest weight. That means that we're going to draw up to 8 packets from that queue for every 1 packet we draw from the default queue. So if there is any traffic in this queue, it will go through preferentially more quickly. And assured forwarding is somewhere in between. It's got a higher weight than the default best effort traffic, but not as high as expedited. So there are a couple of things to note here. The first is that the services, the way differentiated services work, is services are defined as per hop behaviors, so they're behaviors at a router. There's in fact no guarantee of the service you'll get when you stitch many routers together and look across the network, the entire network. It should be better, but depending how many routers you go through, we don't know exactly what it will be like in terms of guaranteed rates and delays. And the other thing is, as you might have guessed, to make expedited forwarding worth it, you need to make sure that there are only small amounts of high priority traffic on your network. So it's not like we can make all traffic be expedited traffic and expect to get better service. If we want it to get better service, we really need to make sure the queues here stay small. So even though it has a high weight, we'll only want a small amount of traffic to go through. So that will be the VoIP for the VoIP call, not your streaming video, for instance. Okay, so now we've seen those three components of the architecture. That's what there is to differentiated services, and you've seen how we can put the pieces together to treat your Skype traffic differently than your BitTorrent traffic. Now, quality of service in this fashion has been rolled out gradually across the internet, but it's pretty slow going for a couple of reasons. And this is sort of one of the unfortunate things about quality of service. The first is that it provides value, the most value, really when it's deployed across the entire network. It doesn't do you much good if quality of service is deployed across your ISP, but not the ISP of the person you're talking to. So you're not going to get appropriate handling in their network. So, this is sort of one of those situations where if you don't have it everywhere, you don't necessarily see the great value. The second problematic issue is that quality of service is fairly tightly tied to pricing and economics. If we don't have some kind of pushback, then there's really no reason all applications and users shouldn't say that all of their traffic is high priority. I mean, I don't know about you, but my traffic's certainly high priority. So I would just like to configure my router to mark everything high priority. That won't work, obviously. We need some kind of pushback here. Often that pushback will end up being reflected in pricing somehow. And this just complicates the rollout of quality of service in the internet. For this reason, the deployment of quality of service has been quite slow and difficult, but it's ongoing and we should expect more of it in the future.